Hi everyone. Welcome to our Tech Talk. Today we're going to talk about how to build a bulletproof Kubernetes dev environment with open source tools. So let me introduce myself. My name is Kuzmin. I'm DevOps Engineer at the Production Engineer team. I'm working on a few stuffs here and there. I recently moved to Production Engineer team. Before I was working in professional services team, and I was facing like customers and their environments. My talk will be a little bit more about what I was doing in the past, not what I'm doing now. But anyway, it will be useful, I hope. There are a few assumptions that I have for this tech talk, but they're not really strict. It will be a huge plus if you have some experience with Kubernetes, and also if you have some experience with open source tools, like, for example, some like Helm, Terraform, and all this stuff that is kind of popular and kind of standard for this for this area of like DevOps stuff and so on. So the agenda for today's talk, so I will give you some definitions and describe what some terminology that I'm going to use during the talk. Then I will describe you why we need this, why we need this dev environment, why it is important, maybe not important, but why it is useful. And then I will show you how I'm doing this. We'll show and describe some core principles, the tool set, and then we will jump onto a hands-on demo in Terminal, and I will show you how to create a dev environment. So what is dev environment in during this talk that we are going to use? So there are a few basic concepts that development environment is can be described with. So there are no business critical workloads. It's mostly like labs, when you can just play around and do some stuff to like test it, or just to test some technology, or maybe test some configuration for a particular application. So you can use it, for example, on a like customer side, or you can use it to enrich your product, etc., or just to teach yourself, just to educate yourself, or kind of like this. Another concept that development environment is about is that each team, organization, or person can have its own environment. So there will be no overlaps between persons. So you can mess around with your environment, and nobody will be affected by it. Also, it's not always the true, but usually it is true that a development environment is kind of limited in terms of resources. So you don't have you don't want to spend money to bring huge development environments just to try something, right? You want it to be really tiny, so you can play around and do some I don't know, POC, for example, so you can prove it that it will work on a production on other environments. And also another concept is that it's not meant to be running for a long period of time. So usually you just create this environment, test something, get some information from it, get some deliverables, and then you just destroy it, and just to not to waste your resources and not to waste your money, basically. So they can be consumed as ephemeral, I guess. So yeah, they're not running for I don't know, year or even month. Usually my dev environments, I'm using them for a week at max. So another concept that I was using is bulletproof. Maybe it's not the super precise word to describe what I meant, but I kind of just like it. So mainly it's about ease of recreation, the environment. So you can, I don't know, install some application on top of this environment, do some configuration of it, and you just break it for some reason. And it's okay. You can just easily rebuild it within I don't know, 10 minutes, for example, and you will get the same environment. So you can again try deploy same application, but just change configuration of it. So that's what I meant by bulletproof. And additionally, it's optionally, it's not really a strict thing to have is that you don't want to have unexpected behaviors, like for example, on your infrastructure part of the environment. So you know what will happen, like exactly when you, for example, create an environment from scratch, you will not see any issues. It's not usually the way it works in a real life, but it's nice to have if you can, define it in some predictable way. It is always good. And also it should be preferably as isolated, so you can, like, for example, don't worry about firewall rules. So you will know that nobody will access your applications, because usually on a dev environment you don't really want to care about security part, because, like, it's security is always hard, and you want to do something quickly, and you don't want to take care about security and and spend your time on it. So if you're using VPN, you're just in a bit safer position. So it's always preferable to do this. But if it's not the case, you can really have a VPN, or you can isolate your environment. That's also good. The reason why we need this dev environment, I will just describe it from like my from the point of view of my experience that I had, is that usually you need to have some playground, for example, where you can. I said it before, but just want to say it one more time. So you sometimes need some playground. So you just get in some information. So you just, I don't know, chatting with colleagues, and you hear like some really interesting tool that might be helpful in your day-to-day operations, and you wanted to try it, like if it's really good or it's like not really good. It's so you just have this environment, and you spin up the application that your colleague told you about, and you test it, and like it can turn out that it's really useful, it's really helpful, and you will include it in your day-to-day operations in your other environments, for example. Another like thing that we sometimes have is like Swiss knife type of environment. It's like the environment that has everything that you need to quickly try. So in this case, the environment can be run for a long term. It's not like ephemeral or something like that. So you can run it and maintain it on like every day. And like, for example, you need some time to access the so for example, there's some environment, for example, stage 1, and you want to monitor it. So you deploy in this dev environment the Grafana, for example, and you can monitor this like remote staging cluster. So you don't need to have you don't need to spin up like a separate cluster or buy some solution, etc. So this will contain everything that you need. And also, like, as a POC, again, so for example, like Mirantis is a product company, right? And we have products that customers buys, and we all want to prove something that is, for example, specific to customer environment. We want to prove like if our product is working with these specific configurations, with the specifics to of a customer's environment. And we can easily do this with this dev environment concept. So that's why we need this. So core principles that I'm using to build a dev environment is infrastructure as a code. So it's like super reliable, right? You can like spin up a cluster in a few minutes using, like, for example, Terraform. I will be using Terraform, but I will jump to it a bit later. The second principle is GitOps. It's cool that you can have all your configurations inside a Git and have like a versioning of it. And also, cool thing about GitOps is that you can share this configuration of your dev environment between team members. So anybody can spin up a cluster really quickly just because they have access to your Git repo. And also another principle is that this dev environment should be like a pluggable system. What I meant by this is that you can add other applications or some custom things, so you can just plug into your like definition of the dev environment, and it will be working. Or you can remove something that you don't need in particular case. Let me describe a bit the toolset that I'm going to use. I'm going to use Terraform as an infrastructure as a code tool. So because it's kind of like an industry standard, right? So it's very, very popular. And it has providers for a lot of different cloud providers. As a user, I will define the things that I need to have on the cloud provider side, and then Terraform will help me to deploy all of them and access all of them. So basically, what I will need is to have a bunch of VMs and like cloud resources like subnets, volumes, etc. So we don't really care about all those things during this tech talk because I will describe it later. And on top of these VMs and cloud resources, I will deploy k0s cluster. So k0s is a Kubernetes cluster. This is really has a small footprint, so it's really easy to deploy it, and you don't need a lot of time to deploy it. And also, you don't need a lot of resources, which is like really good. And from application point of view, we will also use Terraform that will deploy Argo CD on top of our k0s cluster. And then Argo CD will watch for changes in GitHub repo, and there are already some definitions of applications that I want to use, and so it will deploy all other applications. So it's like kind of app of apps concept. So you can have like an application that can deploy other applications. Okay, so now let's jump to a demo. So you can follow along. So I like pushed all the changes that all the code that I will use during my demo to a GitHub repo, so you can access it, I think. Okay, so let me jump to terminal. So I have a copy of my GitHub repository. So here you can see that I have two main folders, apps and infra. So as a first step, we are going to deploy our infrastructure. So let me quickly start the process of it. And then because it will take some time to spin up an infrastructure, during the time of creation, I will just describe what is happening. So let me grab my commands to create it. So also during my tech talk, I'm going to use an alias to just speed up the process. So instead of kubectl, I will just use K. So I already have everything, all the environment variables set. So I'm just going to execute Terraform apply. So so we can see that the process is started, and we have a bunch of different stuff going here. Probably you have a question about like what exactly is happening now and what am I creating. So I'm just executed the Terraform to apply the infrastructure that I defined using the Terraform language. So let me jump to GitHub repo and show you what is happening here. So we have a bunch of .tf files, and each of them, so all these files are in the end merged together, so we can just see each of them separately. So we obviously will need some IAM stuff because we will be creating stuff on top of AWS. So if you want to, I can go into details what exactly is happening here, but I can just, for now, you can just think about this just as IAM stuff that needs to be defined for the machines to be able to communicate with AWS. Machines are defined here in the provision module, in the provision.tf, sorry. So interesting thing here is that we are using the Terraform module that was created here at Mirantis. So it is publicly accessible. You can also access it. It is published on a HashiCorp registry. So here is like the GitHub repo that used to build this module. So basically, it's just a bunch of cloud resources that is needed to spin up either our Mirantis Kubernetes engine or k0s. And so, yeah, we are using it here to ease the process of creation of the infrastructure for k0s. So essentially, it consists of node groups because, node groups is kind of, so it's called in AWS a SG. So it's kind of cool concept because you don't need to care about your VMs to be, you don't need to monitor them, like is they're up and running or no. You can just define a node group, and then you just can't forget about it because AWS will take care about it, about your machines. So like the ingress here is just the load balancer, basically, the AWS load balancer, which is needed to access K0's API. So basically Kubernetes API, because we need to interact with our cluster. So here's where I can describe a bit in more details, like the can answer the question about ingresses and private and public networks. So we have public network for all our machines, and we also have a load balancer that will load balance the traffic for Kubernetes API. But it's not really how it works on AWS, because like usually all your machines have public IP addresses. Oh, and by the way, you need to have public IP addresses on all your machines to create a K0s cluster. But I will describe how to avoid it a bit later. Usually on other environments, on other providers, like for example OpenStack. So this system that I described here, right? It can be used like on any cloud provider. Here, it's not always AWS. It can even be done on bare metal, but it's a bit harder to create a bare metal environment. So it's a bit easier to use cloud provider, obviously. So circling back to private and public networks. So usually on OpenStack, I'm using the private network for all my machines, and I'm just exposing the Kubernetes API and some of my applications, like for example Nginx, with public IP addresses. But all my machines are resting in private networks. So it's just for security purposes, because you don't need to care about firewall stuff. So you are sure that nobody can access your cluster, like your cluster and machines. So yeah, besides that, nodes, we are also creating a VPC, and like that is responsible for networking. So you can go through all this stuff. There's some like utility stuff that, for example, keys that you need to have, SSH keys. It's also creating using Terraform. So you can go through all this stuff afterwards, or you can do this in parallel and ask me a question if you're interested. But I don't think I will go into like much details about what Terraform resources I'm creating. So we can see that I'm jumping back to my terminal. We can see that our infrastructure is provisioned. So we can see that apply completed, and we have created 37 resources. And in the output, we have a k0ctl YAML. So k0ctl is a tool that's used to automatically provision a K0s cluster on top of any environment. So basically, what you need to provision a cluster is IP addresses, the IP addresses that are accessible from the machine that you're executing k0ctl from, and the SSH access to those machines with with the private key and with specific users. The cool thing about k0ctl is that you can pass some configuration options. Like for example, you can use specific version of CNI that you want to use in your K0s cluster, and also a bunch of other stuff. So you can go to K0s documentation and see possible K0s configuration options. I will post all the links like separately. Okay, so now we are ready to deploy our K0s cluster. So I will do it with this command. So I will just get raw output of k0ctl YAML, and we'll pass it to k0ctl, and we'll apply it. So k0ctl will connect to the host using SSH, and will perform a bunch of operations. Like it will get some metadata that is needed for k0s to run, and it will download the binary. So k0s is basically consists of only one binary that will that you need to deploy the cluster. So yeah, it also will like run this binary, and because we have specified the different roles for nodes, I will have one manager, we call it controller in k0s, and 3 workers. So you can see here that we have initialized the cluster on a manager, and now we are validating API connection to our load balancer, to our AWS load balancer that we created in Terraform. This is used to access the Kubernetes API. So yeah, we are just generating tokens and joining the workers from to k0s cluster, and just waiting for k0s services to be up and running. And in the end, we will get like the result that everything is installed. So we just need to wait a bit for it. But basically, we just installing the k0s on top of the environment that we have just created with Terraform. And Terraform has, so here in k0s.tf, so there is a template that is filled in automatically by Terraform with all the public IP addresses and users and paths and so on. So we're just getting this output from Terraform and forwarding it to k0ctl. So k0ctl is installing k0s, obviously. So yeah, it takes some time. Usually end-to-end creation of this dev environment with one controller and 3 workers can take about like 10 minutes. But I think it's pretty fast because you will have a like fully operating Kubernetes cluster in just 10 minutes. So it's kind of cool. So yeah, I briefly showed it here in the GitHub repo. So yeah, you can go through all of them and see some logic here. But basically we'll need, so it will depend again on the cloud provider. That's why I have AWS folder in infra. I'm planning to create a different folders for different cloud providers, and resources that we are creating will depend on cloud providers. So here we are creating like security groups, node groups, VPC, and load balancers, basically, that we will need to connect and and that we need to our k0s cluster to operate. Okay, so this is what sometimes happens. I'm not here to show you like a polished demo, but I'm here to show you like how it works in real life. So sometimes it fails, and we need to investigate why. So k0ctl will tell you what exactly is happening. So sometimes it's just some race condition stuff. Sometimes it's like you can access the load balancer because it's not because it's DNS, right? The domain name, and you need some time for DNS servers to propagate the domain name. So let's just run it once again, and usually it works when you run it a second time. And the cool thing about k0ctl is that it will not do some destructive things when you will run it once again. So it's like kind of this k0ctl apply is kind of similar to concept of kubectl apply, if you're familiar with this. So it will create something or change something if you change the configuration, but it will not recreate it from scratch. So that's also cool because sometimes you just face some networking issues, for example, when you're creating your k0s cluster, and then then network issues disappeared, and you can again run k0ctl apply, and you will have a working k0s cluster in the end. Okay, cool. So there is a tip by k0ctl that you can access the cluster, but in order to access, you need to have config. So again, we will use the k0ctl YAML output, so it's the same config, and we will just execute this command that k0ctl provided us with. And in the end, we get kubeconfig for our cluster that we just created. So I will just export kubeconfig variable for easy to access. And I will show you that we have a running cluster here. So you see we have some pods already here. So like we need to CSI to provision our volumes. We need a Cloud Controller Manager to provision load balancers that are created within the Kubernetes. And we have also a bunch of other stuff like that is specific to k0s and Kubernetes in general. So now let's proceed to application deployment on top of this k0s cluster. So we'll go to root and we'll deploy Argo CD first. Again, all these definitions you can find in the GitHub repo. So it's pretty simple structure. I have a customization file here that contains like the resources of Cert Manager, Grafana, and Nginx, because those are applications that we are going to deploy. And also there is two separate folders, Argo CD and utility. So Argo CD, we will just create a namespace and we will just create a core from official Argo CD GitHub repo. So this is what has happened here. We created some CRDs and stuff that is needed for Argo CD. Then I also have this utility folder that contains the projects that we need to have for Argo CD to work properly, and we also have storage class that will be used to provision volumes on AWS. So as a second step, I will deploy those utility applications. And here we just need to wait for all the Argo CD workloads to be up and running, but I assume that they're already up and running. Okay, so they're all healthy. So now we can deploy our applications, Grafana, Cert Manager, and Nginx. So here we have apps.yaml. So apps.yaml is the implementation of Argo CD's concept of apps. So here we are creating an Argo CD application that uses our GitHub repo, the one that I'm just showing you, as a source, and the path is apps, so the exact folder that we are currently in, and it will deploy on the same Kubernetes cluster where Argo CD is running. So it will deploy everything that it contains in this folder, except for utility and Argo CD, because it will consume this customization file, which contains Cert Manager, Grafana, and Nginx. So let me start the process. So now we can see that Argo CD application has been created. Sync status is synced, so it's already synced with the remote GitHub repo. So basically this one. And we can see that pods will be created. Grafana, Cert Manager, and Nginx. You see that they're just creating like a few seconds ago, because Argo CD took this GitHub repo as a source, and it see that we need, so in customization we have Cert Manager, Grafana, and Nginx, and it understands that it needs to deploy everything that lies in those folders. We can see that everything is up and running. We can also see that there is load balancer created for Nginx that has external IP address. This is basically a load balancer that is created on AWS side. So we can access it through internet, so it's publicly accessible. And with this ingress controller, with the Nginx, we can expose our other applications in safe manner. So you can provide some certificates and all that stuff, and control how and who can access your applications. All this stuff can be configured through this GitHub repo. So for Nginx, we are using Helm chart. Again, it is like Argo CD application, and it takes Helm chart for Nginx as a source here under a specific version, and you also can specify some specific values for this Helm chart. The cool thing also is that you can change some values, or like, for example, the version of a Helm chart here in the GitHub repo by just doing by just changing this file and doing git push. And after some time, Argo CD here in the cluster will understand that there is a new commit, and it will just check if if the application that we have deployed have been changed. And if there are changes, so for example, you change the version here, it will redeploy it with a new version or with the specific values that you have. So it's kind of cool that you don't need to do it manually. You can do it through GitHub repo. And you also will have always the source of truth lays in your GitHub repo. So it's kind of cool. So like I will show you an example here for Cert Manager that we can configure values for the Helm. So we can set the release name. And also I said here that we need to create custom resource definitions as well with this for Cert Manager. So yeah, that's basically it. It took us about, like, I don't know, 15 minutes, I think, to spin up a cluster that we can use to do some plans and do some tests, etc. So we also can add multiple applications here if you want to, or we can change the configuration of those applications and easily redeploy it. Or I don't know, we can change the VPC, the way that we configure VPC, and then destroy the cluster and deploy it again. And it will take, again, like 10 to 15 minutes. So it's kind of cool that you can create such a cool environments that are very useful in that amount of time. Okay, so thank you everyone for attending this tech talk. And also you can use this GitHub repo as a starting point for your investigation. So yeah, thank you.